So today we got medium problem 3932 count k rows in range. So we given some range and number k, and then in inclusive range we supposed to count integers y such that there is some integer x which k power is y. So constraints 10 to 9. So we cannot just iterate over all y and take a square root, because that would be too slow if L is 0 and this is 10 to 9. But k is only 10 to 30. So what we can do instead is notice that already if x is 2, right, if x is 1, then it's always 1. If x is 2, right, because instead of going over all y, we're gonna go over all x. Since 2 to k, like that's at most 30 multiplications, and we will go at most through 10 to 5, because 10 to 5 squared, if k is 1, then we put the whole range. Otherwise, if k is larger, then we just iterate over all numbers up to square root of r, or like kth root of r, and then raise to kth power. We could use like binary exponentiation to do it in logarithmic time, so complexity will be kth square root of r times logarithm of times k, right, or log k, but I mean log k of 30 is nothing, that's like 6, so might even be slower for such small numbers. Okay, so x, I mean 0 to 2 is still 1, so lower, upper, or let's call it like low, high is 0, and then first let's do edge case of k is equal to 1. So if k is 1, then we return r minus l plus 1 since it's inclusive, and otherwise we will take Python. This is easy, we do this, right? So that's because kth root is to the power of 1 over k, because what to power of k is equal to r, whatever, okay, you get the gist. And then for num in range low, high plus 1 inclusive, and it's not int, so I guess let's take int and plus 1 for rounding stuff. And then okay, and for each number we can do like binary exponent, why not, or we can compare two solutions. So if num to the power of k is L num k, I mean I can store the result, so power is this kth power, and then we do like if r, then ans plus equals 1, and we need to have answer, right? And then we run answer and it should pass. I already submitted first try. Okay, so we can see that it's quite slow, so we'll do the binary exponentiation def, and low actually should be L to the power of 1 over k, and then make it to int, right? So we can save some okay, let's run it. Okay, now we are at 0. I mean theoretically we could use this bimpo xy. We don't care about modulo, so that's gonna be quite simple. So answer is 0, 1. And now while it's power of 2, we could do it recursively, but I like the iterative version. So if power is 1, then x is x times x, and then ans times equals, no, here we do ans times equals x, so then we add the answer, and otherwise x times equals x, and we divide the power by 2 and return answer, and then we can use like self bimpo num to k, and maybe we could use it for this, but not sure how it would work for negative numbers. Okay, let's see. That made it slower, I guess, which is understandable because I'm in the 100%, so it's just random. Anyways, math plus binary exponentiation O k root of r times log, or log 2, I guess, of r. I mean, for each of these, so I mean technically it's this because they are independent, but who cares? So going over all y, we will go over all x and just check the condition for xk, right? L less than xk less than r. Okay. And we say the condition is this. Okay, and then what? Okay, so this is, and just check the condition for this, and then okay. Now, first of all, what are the edge cases? Question 1, what are the edge cases? And question 2 is what values of x do we iterate over? Okay, and then question 1, for k equal to 1, we take all values, the answer is all numbers in the range r minus l plus 1, since x to 1 is equal to x for all x, I guess. Question 2, how to make this fast, how to make the raising to kth power faster. Okay, so we have to like answer 2, answer 3. So for answer 2, what values? Okay, so we don't have to iterate over values smaller than k root this. I can write it here in LaTeX, so that's like I had to check how to write k-fruit, but it's essentially this. Since their cave power will be smaller than L, make it into LaTeX because it's inconsistent. R X cave power RL1. Okay, let's rewrite this. Okay, this is dragging on for way too long. Okay. Similarly, we don't have to iterate over values of x larger than square cave root of R, since their cave power will be larger than R. A3, even though k is small, k like the 30, we can still use binary exponentiation to achieve optimal theoretical time complexity by using binary exponentiation. So it's square root KR KL, and then here we do like log 2 of R, I think, no, log 2 of K, so this is log 2 of K. Let's see, and we close it up like LG. Okay, since we iterate over range of all values of x in I don't want to write it anymore, but whatever. Okay. Since we iterate over all values of x and do binary exponentiation iteration power of atmo to the power of k, which takes O log k. I guess so we don't write lg but just log because it's same. For each value of x which takes O per exponentiation, space complexity of 1 since we only use a couple of extra variables post. Okay, day 1 to 3 on the road, goodbye.